Hello everyone, welcome to our channel. Myself Dr. Madhivanandurai, currently working as an assistant professor to the Department of School of Computer Science and Artificial Intelligence at SR University, Warangal. Today I am going to teach the course of modern operating system and computer networks. What is the mean by modern operating system and computer networks? So modern operating systems and computer networks are fundamental subjects in computer science that explain how computers manage their resources and communicates with each through the networks. An operating system acts as an interface between the users and computer hardwares, handling process, memory, files, and system security. Coming to the computer networks, which enables a data communication between devices using a various protocols, addressing methods, and networking technologies. From these courses, which provide the knowledge about this operating system concept such as process management, CPU scheduling, synchronization, memory management, and multi-threading. Along with the networking concepts include network architecture, protocols, IP addressing, transport layers, service, and network securities. These subjects helps to students understand the working principle of modern operating system and communication technology used in real world applications. From these courses, the first chapter or first unit we will discuss about this concept computer networks, architecture, protocols and data transmission. From this unit, we will explore the fundamental principles of network communications, data transmission media and switching technologies that powers our connected world. So coming to the introduction, what is a network foundation? So, network foundation is nothing but connect the devices at globally to share the data and the resources with effectively and enabling seamless communication across the vast distances or wide distances. So, in that data transmission, we will follow the architecture types. There are two type of architectures primarily we will use. So one is a client to server. So it based on the centralized controls. So client to server. This is we can taken as a centralized hub. From the hub and client to get the sources or sharing the resources to show sharing the information with effectively. And second thing is period to period. So distributed sharings. So each node can act as both client and servers. So here each nodes are acting as a client and server to sharing the information to one to another's. So coming to the communication rules, protocols defines the standard rules and procedures for communication between the networks, devices and the systems. So in that communications, there are different layers we will discuss in the upcoming discussions. So, data transmission is organized through layers models such as OSI model, TCP, and IP. So, which provides a structural framework for reliable and efficient communications. So coming to the OSI models, open system interconnection and the TCP transmission control protocols and IP internet protocols. are both logical models. So one of the main similarity between the OSI and TCP is nothing but models that they both describe the how information is transmitted between the two devices across the networks. So the in that OSI models, there are seven layers. One is a physical layer, data link layer, a network layer, transport layer, section layer, presentation layer, and finally application layers. So these all the layers functioned or worked a task at independently. Coming to the TCP, transmission control protocols has five layers only. One is a physical and data link layer, network layer, transport layer, and finally application layer. So it can also be used as a communication protocols in private computer networks. So these are some protocols which will support to the uh, data transmission purpose with effectively. So coming to the open system interconnection, OSI model is a seven-layer conceptual frameworks used to understand and design the network communications. So each layer has clearly defined function and works independently of each other. So we will discuss a layer by layer at what is the function role for each layers. So at first physical layer that transmit raw bits over the physical media. So it deals with cables, connections, or voltage as signals. So it converts the digital data into the electrical or optical signals, then it defines a hardware specific specifications like NIC, hub, and repeats. So it handles the data rate and modulation and physical topologies. Coming to the data link layers, it provides a reliable node-to-node data transmit or transfer. So here the data should be transferred to the node to client to server. So it uses MAC addresses for device identification, and it performs error detection and corrections like a frame check sequence. It check by frame wise and check the sequence of operation to sharing the information and breaks data into the frames and manages across to physical medium. So here the data should be breaks. For example, if we have the data has big size, data should be split as a byte wise as a small size to sharing the data effectively with a fast manner. That's why we call as a breaks the data into the frames and manages the manage across to the physical mediums. Coming to the network layer, the role of network layer is handles the logical addressing and routing of packets. So in the data link layer, the data should be framed as a splitted the data or break the data as different frames or different bytes. It handles the logical addressing and routing of packets, where need to go and routing the packets, how to go, how to reach the destinations. So using the IP address, how to identify the file should be shared to the one to another based on the IP address. So each system has different each unique IP address. Based on the IP address, we will sharing the information to the particular persons or particular devices. So use the IP address for routing distance and determines the best path to destinations. So we need to identify the best path. So shortest way to reach the destination of particular point to share the data at effectively. And manages the packets forwarding and routing tables. Then supports routers and layers 3 protocols. So we will use the protocols to support the routers and layers. So one is like IP protocols and ICMP protocols to sharing the data, routing the data. Coming to the transport layers, which ensure the reliable or faster delivery of data. So transport, as we know, to transfer the data one to another via based on the things we need to share. So here, coming to the network systems, the it ensures the reliable or fast delivery of data, which use the TCP, so transmission control protocols, and UDP. So these are the two protocols are very faster and connectionless. So no need to use any connection or wired data transmission. We go for the connectionless wireless transmissions. And it handles the segmentations and reliability of data. It provides a flow control sliding windows. The flow control of data also important to sharing the data with fast manners. How we need to control the flow control by splitting the data with from the big size and based on the priority of data. So it ensures the error recovery and end-to-end communications. Coming to the section layer, it establishes, manages, and terminate the sections. So in the section layer, it will establish a connection between the one to another to transmit the data, uh, or else we should not share the data one to another or route to one node to another or client to server. So before going to sharing the data one to another, we need to establish a connection between the one to another and manages the data and terminate the sections. If the data transmission is completed, we need to terminate the connection or else otherwise it might be cause any error while transferring the data or after the data. So due to avoiding this error, any issues, we will terminating the connection between the data after sharing between one to another. So it controls the dialogues between the devices and maintain the sections, checkpoints, and the recovery. Also, it possible in the section layer. So it handles the sections authentications and reconnections. So in that sections, it will handle the authentication is whether the right person to sharing the information or else it should be uh, disconnect the connection to sharing the information, and finally reconnection also make it from the session layers, and it used in RPC, the protocols, and SQL sections, and net BAOS. Coming to the presentation layer, it translate and encrypt and format the data. So here the data should be translate one form to another if possible and encrypt the data. Why we need to the encrypt? Because of some, the data should be more reliable and not access to easy someone's. That's why we need to make an encryption of the data, not easy to access the read the files and format the data finally. So convert the data format like encrypt and decoding also. Encoding or decoding also possible at the presentation layer. Then applies encryption and description in SSL and TSL. Then handles the compression for the efficient transmission. So file need to compress to transmit it effectively. Then finally it makes the data reliable or readable for the applicant layer. Coming to the application layers, it provides a service to end to user applications. So who is the person want to receive the file we called as a users. So end to user applications, which supports the protocols like HTTP and FTP and SMPT and DNS. And it provides a network service such as email, web access, and file transfers, and interacts directly with the user applicants. It identifies the communications partners and resources availability. Then the next model TCP transmission control protocols or internet protocols. So in that models, as we discussed earlier, five layers are appeared in the five layers practical network frameworks used for the real world communication, establishing it especially for internets. It defines how data is packed and addressed and transmitted, then routed and received across the networks. So in that models, it quite similar to the same thing what it will do for what happen in the OSI models. So in the physical layers, transmit the raw bits over the physical media, and it deals with the physical hardware like it deals by the physical hardware like a cable, signals, and connectors. It converts the digital data into the electrical or optical or radial signals from one to or from input to the output. It defines the data transmission rates and the physical topologies. Then supports the device includes hubs and repeaters and NICs. Coming to the data link layer, it provides a node-to-node communication and framing the data. So use MAC addressings for device identifications to where we need to share or where at the destination need to send the data. It responsible for the framing, error detection, and flow control of data. Then it handles across the term. It handles access the data and termination the mediums. Then switches operates at this layer. In the network layer, it handles the logical addressing and packet routings. So using IP addresses like IPv4 and IPv6, and determine the best path of destination to reach the data from user to receiver, say client to receiver or node to node. It performs the packets routings and fragmentations, which it includes like what are the protocols we need to use for the transmitting the data like IP and ICMP and ARP, then RARP protocols. Coming to the transport layer, it provides the end-to-end communication and reliability. So it uses the TCP for reliable connection oriented communication, and used for the UDP for faster and connectionless with low overloaded delivery, which means the data flow is very smoothly by the transport layers by data framing. It handles the segmentation, sequence, and assembly. So data should be sequentially flow or transfer from one to another by arranging the data based on the priority or splitting the data. Then provides error detection and correction and flow control in the transmission layer. At finally the application layers, it provides a network service to end-to user applications, supports protocols like HTTP and FTP and SMPT and DNS like that. It is responsible for the data framing or formatting and communication service. It directly interacts with the user application and handles the resources sharing and remoting files access, email, web browsings. So these are the role of in operating system and TCP at different layers. So coming to the differences, the major differences to the open system interconnection and TCP. So it, as we discussed, is a seven layer. So as we know, the physical and network transport and application layers. Here also like that, but it's only five layers. It separates the sections layers, manages the connections and the synchronizations. In OSI model, when come to the TCP models, no separation sections layer and handles in application layers. Coming to the OSI model, presentation layer handles the data formatting and encryption, whereas OS TCP model, data formatting encryption done with application layer only. And theoretic coming to the OSI model, theoretical models developed by iOS for standardizations. In TCP model, practical model developed by DoD for internet uses. In OSI model, each layer strictly independent with clear interfaces. In whereas TCP models, layers more integrated, less strict boundaries. In OSI model, no specific protocols defined, just functions only used. Whereas in TCP model, defines a specific protocols like a TCP, UDP, and IP, HTTP, and etc. Whereas in OSI model uses a reference for teaching network designs, and in TCP actual protocol stack used by internet globally, and finally developed before widespread internet uses. So it was developed before the widespread of internet uses, whereas a TCP developed specifically for A or a PAN net internet implementation. So coming to the physical layer, transmission media uh, overview. So the physical layer serves as a fundamental foundations of all data transfer operation in computer networks like wired media like what are the wired media we use for the transferring the data one to another. So the first we will use for the at initial stage or early stage we were used like a twisted pair cable for LAN and coaxial cable for broadband and optical fiber for high speed connections. So this is twisted pair and coaxial cable for broadband communications purpose and optical fiber for the high speed connections of data transmissions. Currently we are using the most high speed transmission using the optical fiber transmissions. So coming to the wireless media, radio waves for the Wi-Fi networks. So microwaves for long distance like one to another's, and infrared for short range communications. So the choice of transmission media significantly affects the network speed, as we know, and transmission distance and overall reliability. So coming to the transmission medias, how should be performed one to another, sender to receiver? Like a transmission media can be broadly defined as anything that can carry information from source to destinations. So, for example, here is a sender. The file sender send the file to transmission media via transmission media cable or air via wireless network to the receiver. So the transmission media are actually located below the physical layers and directly controlled by the physical layers. In data communication, the difference of formation and transmission media is more specific. The transmission media is usually free space, metallic cables, and fiber optic cables. The formation is usually a signals that use real conversion of data signals. So coming to the wired transmission media, a key characteristics like a twisted pair cables most commonly in LAN local area networks are usually offering the cost-effective connectivity with moderate data transmission at speed range of 1 gigabytes. So it low installation cost. Coming to the features, it low installation cost and easy maintenance and limited distance covers. Coming to the coaxial cables, features superior electromagnetic shieldings. So in that wire, there is a electromagnetic shieldings were used for the purpose. It extensively used in the cables, television purpose, and networks and broadband internet connection purpose. So it's better noise amenities, higher bandwidth capacity, and longer transmission distance also can possible via coaxial cables. Coming to the optical fiber, it delivers exceptional high-speed data transmission over the long distance and complexity immune to electromagnetic interference. The speed of data transmission is very high when compared to those tools. The speed up to 100 gigabytes can be possible. So transmission distance for the 100 kilometers and also possible. And zero electromagnetic interferences. Coming to the fiber optic cables, a fiber optic cable is made of glass or plastic that transmits the signals in the form of lights. To understand the optical fiber, we first need to explore the several aspects of nature of lights. So the light travels in the straight line as long as it moves through the single uniform substance. If a ray of light traveling through the one substance to suddenly enter to the another substance, the ray changes directions. So bending of light rays, there is a three here we will discuss about this three of bending light rays. One is I lower the critical angle. So in that figure, there is a three figure. In that figure, explain the bending of light ray when light travel from more dense medium to the less dense medium. For example, of from water to air, light transmissions. So explanation of these three cases like when I when I lesser the critical angles, the light ray passes from the dense medium, high dense medium, to the less dense medium, and bends away from the normal. So the dense, this is the taking or discussing about the high dense medium. Light passing from the high dense to the lower dense mediums, the light passed away from the normal, so this should be the normal, it's away from the normal direction. This is called refractions. So where here I should be angle of in, incidence, and R should be the angle of refractions, and N1 N2 called as refractive incidence. Coming to the in the second section, so when the I is equal to the critical angles is the refractions. The refracted ray travels exactly along the boundary surfaces. So when the light is transferred to the high dense medium to the lower dense, like a water to air medium, the light ray travels exactly along the boundary surfaces. Along the boundary surfaces, angle of refraction boundaries should be the 90 degree, becomes 90 degree. This angles I is called as critical angles, and it denoted to the sign C n over the n2 over the n1. So whereas n1 greater than this n2. So C is we know already critical angles. So coming to the third category, when I is greater the critical angles, the light does not come out into the less dense mediums. So when light is passed, when I is greater than the critical angles, so the light does not come out from this high dense medium to the lower dense medium. It be reflected back to these high dense mediums. Instead, it reflects back to the complete into the dense mediums. This phenomenon is called total internal refractions. So simply called as a TIR. So coming to the examples, optical fiber communications and diamond spark, and merge effect. This image is little says that the bending rays effect. So wireless transmission media essentials, like what are the essentials wireless transmissions or key features or advantages? So coming to the core technologies, the wireless transmission utilizes the electromagnetic waves to transmit the data without requiring a physical cables connections between the devices. We don't need to implement any wire connections to transmit the data from one to another. The common applications like Wi-Fi, local area network connectivities, are Bluetooth, short-range devices pairings, and satellites globally communications coverage, and cellular mobile networks connectivities are commonly belongs to these networks, wireless network. Common applications. Key advantages of like enhanced mobility and flexibility, simplified installations process also, and reduced infrastructure costs also. And what are the primary challenges in while installing this wireless network connections? The single interference issues and security vulnerability concerns need to consider, and limited transmission ranges also cause. So to avoiding this limited ranges transmission, we need to mount the range between these transmissions at effectively of routers or centralized hub. So coming to the outcomes, classification of primary types we have discussed. In that types, a transmission media, and differentiates between the guided or wired or unguided wireless medias. Comparison of characteristics, advantages, and limitations of common guide media, including twisted pair cables, coaxial cable and fiber optic cables we have discussed, and description of the principles of wireless transmission and categorize the different segments of electromagnetic spectrum used for the communications, radio or microwaves or infrared. Selection of appropriate transmissions medium for given a scenario based on these technical factors like bandwidth, cost, and susceptibility to interference and installation requirement. And as we discussed these layers, what are the layers in the OSM models, tool models, and TCP models, layers and roles. Thank you. Stay on the next lecture.